Jonathan Locke. I'm a product manager with R3, and I'm here to talk to you today about the performance improvements that we've introduced in Corda Enterprise 4.5. And I'm here with
Dimos. I'm a software engineer for R3. I'm working as part of the kernel group, and I was focusing on the performance improvement we delivered with Corda Enterprise 4.5.
Thank you. So just a short summary of what we're going to be talking about today. We're going to be talking about the nature of the performance improvements that we've introduced in Corda Enterprise 4.5. In this case, the performance improvements are mostly targeted at latency improvements. There will be some benefit to throughput, depending on bottlenecks and other things, which Dimos and I will be talking about later. But for the moment, it's mostly latency focused. And we'll also be talking about the way in which those improvements have been achieved, which is through API to send messages to multiple parties more efficiently, optimized flows for collecting signatures and finalizing a transaction, and message compression. And Dimos, in most cases, I guess we'll get down to the details when we get to the slides, but in most cases, a user who has written a Corda app would not need to make changes to their Corda app to get the benefit of these performance improvements, right?
Yeah, that's correct. For most of these features, customers will be able to get most of the benefit without extensive code changes.
Great. So just a bit about the performance improvements that we've obtained. So latency has been the primary metric that we've been focusing on for the past couple of months. So we've been measuring latency and dropping improvements on latency, and it is through parallelism that most of the latency improvements have been obtained. And what this means is that if you have a transaction which makes use of multiple participants, it will scale better. So you may still have a latency impact by adding extra participants to a transaction, but that impact will not be nearly as great as it was in Corda Enterprise 4.4. And we believe that there will be an impact on throughput, although that will depend on other aspects of the deployment, such as whether there are any other bottlenecks involved. But Dimos, would you like to talk a bit more about the latency scaling?
Yes, sure. So before Corda Enterprise 4.5, some of the flows we now improved were scaling quasi-linearly with a number of participants. But now with these changes, these flows will have a constant cost, regardless of the number of participants. So as more participants are involved in the flow, the latency might increase, but this increase will be very small, if there is one. And throughput, as you mentioned, Jonathan, is not directly improved, but it's indirectly, because as flows will have smaller duration, a node will be able to achieve to complete more flows in the same amount of time.
Great. So I know it would be very difficult to give numbers for these kinds of things, but is there any example of a latency reduction that you could give? Even the magnitude of latency.
Yes. So the expectation is that the latency of these flows will be reduced in an amount relative to the number of participants. So, for example, a flow that involves 10 participants, then the duration of the flow will take 10 times less in Corda Enterprise 4.5. Of course, as you said, a lot of other factors have an impact here, like environmental factors or the nature of the application, but that is a ballpark number.
Great. So to be clear, if you routinely make use of transactions that involve multiple participants, the improvement in latency is likely to be substantial.
Yes, correct.
Great. Right. So this is the first slide about the details of what has been changed. So Dimos, would you mind talking through these changes?
Yes, of course. The main capability we introduced in Corda Enterprise 4.5 was being able to send messages to multiple parties in an efficient way. It's important to note here that this was possible in previous versions as well by using the pre-existing send API in flow session. So for example, one application could iterate through a number of parties in a for loop and execute this API multiple times to send messages to multiple nodes. Now we've introduced a new API, which is essentially has two different variations. The one is send all, and the other one is send all map. And this achieves the same functionality, which is sending messages to multiple parties in parallel. But it does it in a slightly more efficient way by causing fewer suspensions and storing fewer checkpoints in the database. And we have these two variations because they target two slightly different use cases. The first API, which is called send all, can be used to send the same payload to multiple parties. And the same variation, the second variation, which is called send all map, can be used to send potentially different messages to multiple parties. And so people that want to get full benefit of this feature will just have to go through their application and migrate potential usages of the old send API to the new send all API.
Great. And I just thought I'd mention that these new APIs do exist in Corda open source, but am I correct in saying that the difference between the versions present in Corda open source and Corda Enterprise, the Corda Enterprise versions are further optimized and faster?
Yeah, that's correct. Because of the way other features of Corda Enterprise interact with this feature, that API is the same from a functional perspective for open source and enterprise, but it is expected to be slightly more efficient in enterprise.
Great. And this means that somebody could start building a Corda app on Corda open source. They can use these APIs in Corda open source, and as soon as they drop the Corda app into a Corda Enterprise node, it will be much faster, right?
Yes, definitely.
So the next change which has been made are the optimized flows. So Dimos, again, would you mind talking us through these changes?
Yeah, sure. So there are two basic flows that have been improved in this version. The first one is called the collect signatures flow, which is responsible for sending a transaction to a specified set of parties and receiving a signature from all of them. And the second flow is finality flow, which is responsible for finalizing a transaction through the use of a notary, and then sending the finalized transaction to all the involved parties. Those two flows share a common characteristic, which is that the same kind of payload needs to be sent to multiple parties. And this is where the biggest part of the benefit is gained by parallelizing this aspect. So the new versions of these flows on the first part will be collecting signatures from multiple parties in parallel for the collect signatures flow. And in the second case, they will send the finalized transaction to multiple parties in parallel.
Great. And I see there's some notes at the bottom there. So no need for code modifications to benefit. So you will not have to change your existing Corda app in order to benefit from these changes. But am I right in saying that you will see the greatest benefit if your transaction involves multiple parties?
Yes, exactly. So the bigger the number of parties that are involved in the flow, as we mentioned before, the larger the benefits you will expect from using the newer versions of these flows.
Great. And I know that there was a change to backchain resolution in Corda Enterprise 4.4. How does that improvement to the speed of backchain resolution in Corda 4 4.4 interact with the changes here?
Yes, that's a good point. So in the previous version of Corda Enterprise, we released another feature that improved the aspect of backchain resolution. Essentially, what this feature does is, while resolving a backchain of transactions, a node can be exchanging multiple states at a time to speed this process up. But this was only happening on a per session basis. So in this case, we built on top of this feature, and we also parallelized across nodes. So the combination of those two features from 4.5 and 4.4 are expected to give a very significant latency reduction, especially for flows that involve a large number of participants and big blockchains.
Great. And the last slide on the performance improvements that have been introduced in Corda Enterprise 4.5 is the message compression feature. Dimos, would you mind talking us through this, please?
Yeah, sure. So with Corda Enterprise 4.5, P2P messages between nodes can now be sent in a compressed format. And this can lead to improved performance, which might manifest both in reduced latency and reduced round trips, and also in improved throughput. Great.
And so this is, of all of the performance improvements that we've made to Corda Enterprise 4.5, this one doesn't depend on having multiple parties in a transaction, right?
Yes, that's correct. This can be beneficial for many different cases, and it will depend on some factors like your environment. For example, environments that have networks with lower capacity and smaller bandwidth are expected to benefit more from these changes. And also applications that have larger payloads that are exchanged between nodes are also expected to get bigger benefits from this.
Great. And am I right in saying that one of the reasons why message compression is so beneficial for Corda Enterprise is because when a flow creates a checkpoint, compression will mean there's a smaller amount of data that has to be serialized. Is that true?
Yes, that also gives that also has a partial gain. The fact that things that are stored in the checkpoint are smaller, and the second aspect is the fact that the payloads that are sent through the network are smaller in size. So a smaller load is imposed on the network essentially.
Right. And there is a slight CPU overhead. I imagine any compression and decompression involves slight CPU overhead. But am I right in saying that from the testing that you've done, the CPU overhead is easily small enough that the performance gains from compression easily outweigh the CPU cost, right?
Yes, that's true. In most of the cases, we performed some measurements, and in most of the cases, we saw that the overhead of the CPU overhead wasn't really significant, and this feature is expected to give gains to most of the use cases. And this is part of the reason the feature is enabled by default from Corda Enterprise 4.5 on all nodes. But we still give the node operators the option to turn this feature off if they want through the node configuration using the new option called Enable P2P Compression.
Great. And one last important thing to note, as you can see on the slides, that Corda Enterprise nodes can compress and decompress, so they get the full benefit of the compression performance improvement which we've added. But Corda open source nodes can only decompress traffic, which means that they can interoperate with Corda Enterprise nodes without any problem. But the Corda open source nodes operating alone will not gain the full performance benefit. Dimos, thanks so much for your time today. Do you have anything else to add?
Thank you very much, Jonathan. No, I think that's all.
Thank you.
Thank you.